All right. Purpose of this one is the purpose of this video is based on AC Systems Lesson 2, where we're going to talk about vectors. A lot of students will ask me, why are we learning about vectors in AC systems? And I don't know, who you guys had for first year and whatever situation you're in. AC theory is going to be based on DC theory, but we're also going to talk about a phase relationship because it's not always in phase like it was in DC, and we're going to explain that later. But we will be able to utilize vector relationships for that. So we are going to be talking a lot about sine, cosine, tangent, mostly cosine, but we need to learn and understand how vectors work and how they're set up and how to solve for them. So in this case here on the drawing that I have on screen, you'll see I've got two vectors, and the vector 1 and vector 2, obviously. Basically the difference between a vector and what is called a scalar is that a scalar is just an amount of distance. You are 5 miles away from me. That is a scalar because I'm just giving you an amount of distance or a magnitude. A vector means I say that you are 5 miles east of me. That is a vector because not only do I have a magnitude or a distance in this case of 5 miles, but I also have a direction of east. So I have to keep that in mind. So I want to really quickly review graphing. So this is our 0 here, and this is a 0 here. This 0 right here is on the x-axis, and this one is on the y-axis. Everything above the 0 on the x-axis is going to be positive. Everything below the 0 on the x-axis is going to be negative. Everything to the right of 0 on the y is going to be positive. Everything to the left on the y is going to be negative. Okay? That is where we're going to start. So there are a few different ways they can ask these questions on for our vectors. For one, in this case, we have an initial point. Our initial point is, what point does this start? And it starts right here at that location right there, vector 1. So vector 1's position, or initial point, we have to start, and we have to do this, it's called XY format. So the X is going to be the first value, and the Y is going to be the second value. So if we look at our X value, which is based on the horizontal, we can see that that is at -2. So our initial point is, actually, let me do it over here. My initial point for vector 1 is -2 on the x-axis, and on the y-axis it is -5. We can see it right there, -5. So now I want to find what is called the terminal point. The terminal point is, where does it end or terminate? So it terminates on the x-axis. We draw that right there. It terminates at 6 on the x-axis and on +5 on the y-axis. So we can see that this vector v1 goes up, so to the right. So when it goes to the right, we said that anything going to the right on the x-axis was positive, and we can see that it goes up, and anything that goes up on the y-axis is positive. So we know what's called the component form is going to be both positives, right? Because it goes up and to the right. So my component value is going to be solving. I solve it by using subtraction. So just like if I told you that at the end of the day I had $100, my terminal point was $100, and my initial point for the day I had $25. I can take that 100 minus 25, and I can say that I made $75 today. So we're going to be able to do the exact same thing with our initial and our terminal point. The one thing that we've got to remember for sure is we are going to take this -2 and -5 and we are subtracting those values. So if I subtract a -2, that's the same thing as adding a +2. Do we all remember that from math? So when I subtract a -2, that's going to be like adding 2. And when I subtract a -5, it's going to be like adding 5. So now I have a 6 plus 2 in this case, which is 8. And a 5 plus 5 in this case, which is 10. So my component value of this vector, how far does it move across the x-axis and how far does it move on the y-axis? We see that it moves 8 to the right on the x-axis and it moves 10 up on the y-axis. And we can, if we really want to do this cheap, this comes all the way down here. I can't draw a straight line for this, but it goes there. So there's 1, 2, 3, 4, 5, 6, 7, 8. Yay. And it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up. Look at that. Worked like a champ. All right. So we're going to do the same thing with vector 2. I'm going to do it on the other side of the screen. I'm going to draw that in blue. So let's take a look real quick. Where is my initial point? You can see that it is right here because it does not have the arrowhead on it. And that is on the x-axis, it is +2. And on the y-axis, it is +2. So my initial point is 2, 2, x and y. My terminal point on the x-axis is -3. And up here, +8. So we can see that that now is going to the left. So since this one's going to the left, I should get a negative value for my x value, but it still goes up. So I should still get a positive value for my y. So let's subtract them. Now I'm subtracting two positive numbers. Subtracting positive numbers is easy. I just subtract now. So I'm going to do -3 minus 2, which should be -5. And we knew it had to be negative because it goes to the left. And 8 minus 2, which is 6. So that should be my component. And again, if we really want to check ourselves, this again, straight line, not going to be my strong suit here. It looks like it goes right to here. So that is on the x-axis, 1, 2, 3, 4, 5, which is right. 5 to the left, which is negative. And 1, 2, 3, 4, 5, 6 going up. So we are rocking. Super duper. All right, so that is using our graphs. Now, hopefully you guys learned some of this last year when you did trig in first year. Hopefully everybody remembers SOHCAHTOA. SOHCAHTOA. So I'll draw it up here. SOHCAHTOA. Where SO is sine of theta equals the opposite side over the hypotenuse. The cosine of theta equals the adjacent side over the hypotenuse. And the tangent of theta, which equals the opposite side over the adjacent side. Going. So, keep in mind that sine is a function, cosine is a function, tangent's a function. It's just basically a relationship of two of the sides. Okay. So, in this case here, I am looking for the sine of theta. Because what I'm ultimately going to look for is going to be the angle of theta. And we're going to be able to find that, I pinky promise. So if I take the sine of theta and I know that that is the opposite over the hypotenuse. So the opposite over the hypotenuse in this case, the opposite side. So again, here is angle theta. The side opposite that is 12. The hypotenuse is always going to be the longest side in a right triangle. So in this case, it is 20. So 12 over 20, we can bust out our trusty calculator. It's gonna be 0.6, but when I bust out my trusty calculator over here, where's my cursor? There it is. I'm gonna take that side 12 and divide it by 20, and I'm gonna get a value of 0.6. That is going to be my sine function for theta. I'll switch colors here, and I'm gonna go with the cosine. Obviously, the cosine is gonna be a different value because I'm now using the adjacent side, but I'm still using that same hypotenuse. In this case, the adjacent side is the side that touches theta, but is not the hypotenuse. So in this case, it is 16 over 20. That should be 80%. Let's get out our calculator though, prove it. 16 over 20. And there we got 0.8. So we're good so far. Last but not least is going to be our tangent function. Tangent function we'll do in green. And that is going to be the opposite side over the adjacent side. In this case, the opposite side of 12 over the adjacent side 16, that is 3/4. But we will prove it by putting 12 over 16. And there it is, 0.75. All right. So that's great. That's fantastic. We know these values now. What is the value of angle theta? Well, if I use sine and I use my opposite over hypotenuse, which I got 12 over 20, I'll plug that back in, 12 over 20. I get my value of 0.6. My scientific calculator, now with your guys' calculators that you bought from the JATC, you can actually just hit second sign, second answer on this one, or if you're kind of a math nerd, you can just hit sine first. And when you hit sine, I'm sorry, you have to hit inverse sine because you're looking for the actual angle. We'll talk more about that in class. But what I'm going to do, so you hit second sine, and then that would give you sine to the -1 in a parenthesis, and you can just put the 12 divided by 20 in there, then hit equal, and you'll find out your value of theta. So in this case here, I've got my value of 0.6. I've got to go to my trig function, and I'm going to go to the inverse of sine. And that tells me that I've got an angle of 36.87 degrees. So that is 36, oops, I'm in green still. So using the sine function, it says it's 36.87 degrees. All right, so now let's go ahead and use our cosine function because, well, we'll do that now. Using the cosine function, 16 over 20, we got our value of 0.8, and I'm going to go into second cosine. What do you think we're going to find? There it is, 36.87 again. It's 36.87 because I didn't change anything but what function I was using for that. So knowing that, I'm going to guess that my using tangent, it's also going to be 36.87. So let's bust out our calculator and find out. 12 over 16 gives me a value of 0.75, and my inverse tangent on that, 36.87. So whether I use sine, cosine, or tangent, as long as I use the right values, I am going to be able to figure out what my angle theta is equal to. Okay, and those are going to be very important, but like I said, we are going to be using cosine for the most part, and we'll explain why a little bit later on when we get into that. So let's just say all I do is I give you a vector. And I tell you that that vector is 100 units long at 35 degrees. I want to find out, I want to figure out how far did I move that on the x-axis and how far did I move that on the y-axis. So I think I can do this. So I've got this here. And I'm going to go to this point right there. All right, and I want to figure out how good can I get that? Can I get pretty close? There we go. So I want to find out what my x value is and what my y value is. So how can I do that? Well, knowing that this is angle theta right here, I'm going to go back to red. Knowing that this is angle theta, 35 degrees, I need to use one of two formulas right now because I don't have the opposite side of it. So this is the opposite side, right? And this is the adjacent side. I don't know either of those. So I can't use tangent because I would need to know either the opposite side or the adjacent side. But I can use sine or I can use cosine. If I use sine, I would be finding the opposite side because I know what angle theta is, I know what the hypotenuse is. If I wanted to find the adjacent side or the x value, I would use cosine because that is the adjacent side where I know the angle and I know the hypotenuse. So let's prove that we can do that. First, I'll use my red pen and we will solve for the y-axis value or the vertical value. And that, because I'm using the opposite, that is going to be sine of theta equals the opposite side over the hypotenuse. So the sine of theta, I know what the value of the sine of theta is, right? If I hit my calculator and I hit 35 degrees, we clear that. I put in 35 degrees and I go with the sine value of that. I get a sine value of 0.5, I should have written it down, 0.57 something. .36, we'll just say. Equals the opposite side over the hypotenuse, which is 100. Now, one of the things I like to use when I talk about math and all the other stuff is that I can make any value I want a fraction if I put it over 1. So now I've got 0.5736 over 1 equals 100. So I think what I'm allowed to do now is I'm allowed to cross multiply. Does that sound logical? So I'm going to take 100 and I'm going to multiply it by 0.5736. So what I'm going to do is I'm going to go back to my calculator here. And I'm just going to take that value and I'm going to multiply, it's still in my calculator, so I'm going to multiply that value by 100. And I'm going to see what just happened. Nope. Equals 57.36. I don't know why I was doing that. So my opposite side is 57.36 equals hypotenuse times 1, which is just which is opposite times 1, which is just the opposite side. So 57.36. Now, there are two different ways that I can solve for my adjacent side. When I go to solve for my adjacent side, like we talked about before, well, actually, there's a few different ways. I can use tangent now because I know the opposite side. Or I can use cosine. So we'll do that one first. Let's figure out using cosine. The cosine of 35, cosine of theta, equals the adjacent side over the hypotenuse, which in this case is 100 still. So I'm going to figure out what the cosine of 35 is now and multiply that value by 100. Now the one thing, well, let's do it first. 35 cosine times 100 equals 81.92. So 81.92 would be the answer over here. What I want you guys to pay particular attention to, if you're using your calculator for this, if you hit the cosine of 35 on your calculator is going to look like that. If you hit times 100 in there, you're not finding the cosine of 35 times 100. You're finding the cosine of 3,500 degrees. You do not want to find that. If you hit cosine, it automatically puts that parenthesis in there. If you put in the 35, you have to close that parenthesis before you multiply it by 100. The way that I escape this is I put the 100 in first. I took 100 times cosine, and that's what your calculator will look like. Now you can just hit equal and it'll find the cosine of 35. You go? Or you just close the parenthesis. That's what I will say the non-lazy people, because I'm one of the lazy people who tries to save keystrokes. Another way I could do this was with tangent, but I'm really not going to get into this solving it with tangent. If I still don't know what this value is, though, I can use Pythagorean theorem, right? We know that a squared plus b squared equals c squared. But I know c squared, that's 100 squared. And I know that we can use whatever side. We'll say that this is 57.36 squared. And we're still looking, we're looking for this side right here. We can just take our 100 squared and subtract 57.36 squared. And that'll give us our side A. So we can do that. Once we get that second side, we can use the Pythagorean theorem. I just want to clear this side up. So when you look at the last group of questions, this question right here stretches, Jesus, come on. This question here stretches into 2, 4, 6, 8, 10, 12, 13, 14. I think this question goes to like 14 questions. This picture right here draws up about 14 questions on your homework. So I would at least like to take a look at it momentarily. A lot of them are pretty easy. We just have to pay attention to what the question is asking. The first couple questions specifically talk about vector 1, and it says, what is the x component or y component? I think it starts with y. So how much does this move on the y-axis or vertical axis? Well, it doesn't move anything on the y. And how much does it move on the x? It's a positive 10 because it's going to the right. And then it asks the same question about vector 2. How much does it move on the y-axis? Well, it moves positive 10 because it's going up. How much does it move on the x-axis? 0. It doesn't go any left and right. This is negative on the x. This is negative on the y. We got to do our sine cosine thing with that one, and the same here. All right, be careful because we know that this one here, the one vector 5, is going to be positive and positive, but vector 6 we can see is going to be positive x, negative y. So we have to pay attention to that. With the last couple questions we're going to ask, and I really just want to see if you guys can do it, we'll see that vector 1 goes 10 this way. And then what it's telling you to do is connect them head to tail. Or tail, yeah, head to tail. So this goes 10 this way, and then this one goes 10 this way. And then it goes 4 this way. And then it goes 6 this way. And then it goes that way, and then it goes that way. What your last couple questions are asking you is, how long is that distance, and what angle is it? So I want you guys to take a stab at that. I'm not expecting perfection, but I'd like to give you guys a fighting shot at it. Good luck.